we can take this as one end and this to be the remote end, something like this is initiator and this is responder. Okay, so let's enable them. So let's start writing the configuration first. Okay, so we know what are the configuration that we would be using it, the encryption, authentication, df value, all those things. Okay, so I'll make use of some notepad first to write this configuration and then we can copy paste it. Okay, so let's say these are the two routers, right? So one is Japan R15 and the other one is Australia R16. So I'm starting with the first one, that is Japan. Okay, so for the first one, let's start writing the IKE phase 1 configurations. Okay, so I'm gonna go to the config mode of this box and then I'm gonna start writing the commands. So let's say crypto ICKMP. As I told you, ICKMP is nothing but IK phase 1. So crypto ICKMP, I'm gonna define a policy call as 10. Anything, it can be anything, it can be 100, it can be 30. So it's basically gonna, let's say your router has 100 of VPNs, right? So each VPN can have their own policy. So we need some numbers. So let's say this VPN is between Japan and Australia. Let's say you have one more VPN coming up next week where you need to have different parameters. So you can assign it the policy number 20. So that is why we keep this, so they can have different VPNs on the same box, on a same device. Okay, so crypto ICKMP policy 10. What are the values we been provided? We are being provided with these values for IK phase 1. So let's start with the hash value. Okay, so over here we have hash 1, we can go with MD5, we can go with SHA 256. Those are all supporting protocols. So let's go with something a smaller unit. This is just a lab, right? So I'm gonna go with hash MD5. Similar way, it's talking about now about the authentication steps. So what are my authentication step? It's a pre-shared value. Okay, so I'm gonna say, so I'm gonna say authentication that I need is pre-share type, not a digital certificate. What else do we have from here? So we have something for DH value. Okay, Diffie-Hellman group. So I'm gonna say that I want it to be group 2. What is left? It says encryption. As I told you, we have AES 256, we have AES, we have DES, we have 3 DES, right? So let's go with something for encryption as well. So let's say I need 3 DES. Okay, so this is your IK phase 1 parameters. Now let's define uh, the key, because the key is been called out. Okay, the key is been given to us, so we are gonna say we need something for key now. So let's say crypto ICAKMP key, we can go with this, no harm, copy and paste it. Okay, and who is on the other side, that is with whom are we trying to build the VPN? So what is the IP of that device? So I'm over here on Japan. Okay, so I'm over here, I'm trying to build the VPN with this guy. So this is my remote IP, right? So we will consider that. So let's say the address of that router is 12.1.2. Okay, and let's define some IPsec configurations. So we have to define IPsec configuration for AES256 SHA-1. Okay, now there can be many parameters apart from AES256. We can have something for let's say ESP3DES. Okay, same way over here we can have something for ESP uh, MD5HMAC. So these are all the different hash technology and encryption technology. I'll show you this while I am doing it on a router. We can do a question mark and it will let us uh, have multiple options and we can pick one from that. Okay, so let's say I'm now starting with some IPsec transform set configurations. Okay, so let's say crypto IPsec transform set. Let's define some name. So let's say this is Japan to Australia. Okay, we are gonna define the value for encryption ESP3DS and we are gonna define a value for hash. So this is what is called out in this word, and this word will be used later on for further configurations. Now, as I told you, we don't want every LAN users to access the server. We don't need marketing to access the server or sales team to access. So we are gonna apply some access list, and we are gonna define who are the end users who wanna access this, or who is allowed to be passed over onto this VPN. So let's say access list 100. We are only allowing 1.1.1 to reach 2.2.2. So these group of users are behind Japan LAN segment and these are behind Australian LAN segment. So these all communication is been given to us over on this template. So if you see from this template point of view, we have been provided with internal project. So this is nothing but that 2.2. series. So because of this template only, we are building the VPNs. Okay, so where's my notepad? Okay, fine. So we have defined access list. Now let's define very similar way like how we did the phase one, right? So we are gonna make use of the same sorts of thing for IPsec or phase two also. Okay, I'm gonna say crypto map. I'm gonna call this crypto map Japan to Australia. I'm defining the policy number and I'm just telling that this is IPsec ICKMP parameters. I'm gonna define my peer IP. So who is my peer IP? Peer is nothing but the Australia. So Australia is located at 12.1.2. I am gonna tell the match address. Match address is nothing but I'm calling this access list within the phase 2 parameters. I'm gonna say match these group of people. Only these group of people are allowed to be passed over on the IPsec tunnel, the phase 2, the step number 2. And then set transform set. And what is the transform set that we are using? So we are using this. Okay, so crypto map, we can make use of some other word so that we don't confuse with all the same names. So let's say this is for Japan to Australia. Okay, Japan to Australia. I'm saying this is the IP of Australia, the other side. These are the users they can access. So this is one side, this is the other side, and the transform set, that is something which is already given to us on the template. And now we are gonna define which interface you want the VPN to be terminated on your device. So you are gonna say the interface. Okay, so which interface do you have here? It's E0/0. So if you see here, E0/0 and E0/0. So that is something which you need to define, that these are the interfaces that are actually gonna be used for VPN termination. So I'm gonna say interface E0/0, and you're gonna define what VPN you are gonna call it here. So this is the VPN that I'm gonna call here, crypto map Japan to Australia. And once you do that, we will do some routing as well, because routing is required so that your internal users know that from source to reach destination, go via this path. Okay, so I'm gonna say IP route 2.2.2 255.255.255. Let's go with we can go with 0 or 255 and make use of this interface. That's your out facing interface. Okay, and then where are these people? We have not created them, right? So let's create some loopbacks for our testing purpose. So let's say these are loopback. I'm gonna say they are 1.1.1 and 255.255.255. We don't need no shutdown for loopback, they're always up. Okay, so if any confusion, we can go with 0, so it doesn't matter anything. Okay, so these are some configuration that is done on Japan side. I can take the configuration, I can copy them, and I can also keep it for Australia. Okay, but remember, we have to do some changes. We straight away cannot uh, uh, copy paste, because there are a lot of things which will get changed. Now these will be not 2, this would be 1, right? So we will do that. Let's go step by step. So phase 1, you're going to make use of the same parameter. If you don't, then they will not come up, so we don't need any changes here. Crypto ICKMP key has to match. If you don't, then they will not come up. But now the peer will be 1, because you are already on dual.2, so you are here now, right? So for you, this is the peer, which is 12.1.1.1. Okay, so that is defined here. Let's go to next step, that is transform set. We don't need any changes here, because if I change something, then VPN will get disrupt, right? So we will not change that. ACL will be changed, because now the source and destination are being changed or reversed. So we will have 2.2 here, and we are gonna mention 1.1.1 here, so vice versa. Okay, crypto map Japan to Australia. If you want, you can change the name, doesn't matter. Okay, now you can say this is Australia to Japan phasing. Okay, 10 IPSec CCNP set peer is now on 2. Okay, I think yeah, okay. So this is 2.2.2, this is peer, this is peer. Yeah, so this I just now had done. Okay, so this is dot one Japan side. Match and match address 100. Okay, set transform set J Australia. Once again, this is locally, so you can change this if you want, but make sure you use the same word while you're doing over here. What is the crypto map that you need to apply over on the interface? You're calling that. Now the IP route will change, because now you're talking about 1.1. So any traffic that is going for 1.1 will take this interface, and you will create a loopback here, which is 2.2.2. Okay, so this is the VPN configuration. So let's start applying it on the real box. So here's my real box. So my real box is here. Let's start with Japan first. I hope you guys are with me. It's all good, right, so far? Okay. Okay, so let me name this as Japan R15, and let me rename this as Australia R16. Okay, now time to copy paste. We can just copy paste. If you wanna see, then I can show it for one of them. So crypto ICKMP policy, if I do a question mark, it lets me to select any of them, any of the numbers. And as I told you, this is from identification point of view, because this VPN is between Japan and Australia. Might be next week you have to create another VPN from Japan to Singapore. So you might have received a template, VPN template, and they are talking about a different security parameters. So you cannot use the same policy, right? So that's why we need a identification. So we will create 10 hash value. If I do question mark, you can see lot of things. Okay, MD5, SHA-256, SHA-384, 512. So what have I taken? I have taken a lowest one, MD5. If you go with authentication, now it says that do you need the digital certificates or the signatures or or encryption, or you just are good with pre-share. So let's go with pre-share because that is what given to me. Let's go with the next step, group. Now as I told you, Diffie-Hellman comes with some strengthening of this pre-shared keys. You want to go with 768 bit of strengthening, you can make use of group 1. If you want to go with group 2, you can have 1024 bit of strengthening. So these are all strengthening type. Okay, but remember, the more strength, more you take the strength values, it the routers take a lot of time for encrypting or encapsulating, and on the remote side it is gonna take once again so much of time for decapsulating. Okay, so the higher value you go, then it takes more time for encapsulation and decapsulation. So most of enterprises will not prefer, but let's say if you're dealing with some banking sector or finance sector and you need a very high tight security, then you will go with very high values. But any other enterprise, you can go with group 2, which is something widely used. So let's go with group 2, and then we go with encryption. If I do question mark, I can see the different values. So we have considered 3DES. So this is my first block of configuration. Let's define the pre-shared key now. So let's say crypto ICKMP key. If I do a question mark, it says that I can enter the key. So let's copy paste from this, paste it here. And what is the address of your peer key? Okay, so the address is 12.1.1.2. Enter. So we are done with the first step. The first step is the phase 1. Now let's start with the IPSec configuration. So let's say crypto IPSec transform set. Let's define some word. As I told, let's go with Japan to Australia. I have so many of options with me. Okay, so I cannot go and take any one of it. I have to follow my template, the template what the other user is using. Otherwise, I'll face mismatch concerns. So I have prepared the change plan, right? So I'll take this one, ESP3DS. If I do question mark, once again I am being prompted with lot of option. Once again I have to see my template that's been provided by the customer or the other side of user. So this is my transform set which I have defined. Okay, and this is the name for this transform set. Let's define the access list now. So access list is basically who is the source and who is the destination. We don't need all of them to use the VPN tunnel and choke the tunnel. Okay, so many users using the tunnel will of course choke the tunnel, right? If all the LAN traffic start using the tunnel to access Google or Facebook or something, you're basically choking the tunnel. So you are giving it one-to-one point of view or network to network point of view. So access list 100, permit only IP to IP. we are defining the two users. This is on the Japan side and this is on the Australia side. Okay, now we will go to the IPsec parameter where we have to define the parameters, like what are the ACLs we need to call, who is the remote side IP, what is the encryption and authentication that we have called upon. Okay, so I'm gonna say crypto map Japan to Australia. Let's define the numbers. This numbers, keep it same, so that you always come to know that while you troubleshoot, you always come to know that 10 was for Japan to Australia. Let's say there is some issue going on with Japan to Singapore, and the numbers you allocated for that Japan to Singapore was 50. It becomes very easy for you to troubleshoot. You will go with show run, you will search for the configuration under 50. You will see whether the phase 1 parameters are good or phase 2 parameters are good. So numbers are gonna help you. So if you make use of 10 here, 50 here, troubleshooting becomes very difficult, because 50 IPsec, if you are using 50 number for something on the phase 1 for some other VPN, so there will be a lot of confusion. So keep a same number for phase 1 and phase 2 for one particular side of VPN. So we are making use of 10 for Japan to Australia. So it is easier when I do a troubleshooting as well. So it says that when I'm starting with crypto map, it says that there are some missing values. Okay, this new crypto map will remain disabled until a peer and a valid access list has been configured. So these are the two values that it's actually asking me to enter, and I'm gonna get this warning message every time, because until or unless I define this, my IPsec is not actually defined properly. So I'm gonna do that. I'm gonna say set peer is 12.1.1.2, and I'm gonna say the ACL to be matched is 100, and then I'll define my encryption, and this is JOST. Okay, so that is the same word I'm using, right? JOST. Okay, I think for some reason I came out of that. So let's go within this and let's define the transform set. Okay, so we are done with that. IPsec is done. Now it's time to define who is gonna take the responsibility for VPN traffic negotiation. Okay, so you are gonna say that this is that interface where the VPN packet will be negotiated. These are the two. So in a router, we just define them. But if it was a say firewall, you would have defined something called as crypto outside, crypto inside, crypto interface outside. So basically, you're gonna tell that these are the interface that's gonna ultimately respond or negotiate for the VPN parameters. So we will do that now. So I'm gonna say interface, it's 0/0, and I'm gonna say crypto map, it's Japan to Australia. As I told you, now it's so VPN part is done. Okay, but VPN is not just gonna do end-to-end transfer, because setting up VPN is one part and then your routing is another part. If your VPN is good, so let's say if the same configuration I do it on the second side, we can test the VPN and we can bring the VPN up. But what about the data that you're sending over the VPN? That needs routing. Routing has to be done. That is how the data has to flow inside the inside this VPN tunnel, right? So let's say if the routing was missing, which happens in the production, most of the time what happens is you have done your step of constructing VPN. So both phase 1 and phase 2 are up. But then you get some issues where the traffic is not entering. That's because the routing is having some issue. the LAN part of routing is not good. So we are gonna put some static route, and we are gonna tell that for destination 2.2.2 always prefer the VPN tunnel. The moment will start entering to the VPN tunnel, the VPN will also start with negotiation. The VPN will come up. Once the VPN is up, the traffic can be seen flowing across on this direction. Okay, so routing is also one important part in IPsec. So right now we just did with IPsec. So let's do some routing also. I'm gonna say IP route 2.2.2, which is on subnet 255, and on which interface is this to be sent. So it is 0/0. If it was ASA firewall, I would have typed it's a outside interface. Since these are routers, I'm gonna say they are all on 0/0. And for testing purpose, we will create some loopbacks. I'm gonna say this is 1.1.1 with network of this. Okay, so this is my configuration on one side. Now on the other side, I'll just copy paste what we just did. It's the same thing. I don't want to take a lot of time for once again doing the same thing. So we'll do copy paste from one step to other step. Okay, so the first step copied, the second thing is gonna get copied. Okay, the third step is gonna get copied. We are now gonna copy this access list. Done. We are gonna copy the IPsec now. Fine. We are gonna enable the interface. We are gonna do the routing, and we are gonna do the loopback for testing purpose. Okay, so what do you think? The VPN is up now? No, the VPN don't come by itself. We have to initiate some packet. Okay, so if I do see show crypto ICKMP SA, so you see there is no VPN at this moment. This is phase 1 testing. If you so there's no phase 1, there's no point of seeing phase 2, because the first thing is phase 1 that comes up, and then the phase 2 comes up. Okay, so show crypto ICKMP SA itself is down in the sense we have not initiated some packet, so there's no way the negotiation is gonna happen. You have to push some packet, so the negotiation starts happening. If the negotiation is good, then the data will flow in and out. Okay, but I'm just showing you the commands. Okay, so show crypto IPsec SA peer, and what is the peer IP from Japan point of view? So it was this one. Peer IP is nothing but the Australian outside interface. So what do we see? We see that configuration, but there is no packet. Okay, packet is 0. Encap is nothing but Japan to Australia. Decap is nothing but the return traffic from Australia to Japan. So this is also very important while you troubleshoot. You will see not most, you might see sometimes some few scenarios where encaps will start increasing 0, 1, 2, 3, 4. It started increasing, but decaps is shown as 0. So what does it indicate is your side of routing, your side of packet, that is 1.1.1. Network towards 2.2.2.2 is good, but the return traffic from 2.2.2 to 1.1.1 is not working. Now this directly leads to the VPN routing issues. You will talk to the remote side. You will tell that person from the Australian data center that your side of packet is not coming inside the VPN tunnel. That means your routing is not working well. So check the routing. So basically you have to put this statement so that his 2.2.2 start entering the VPNs. Okay, so we will see that. Let's try to bring up the VPN now. Okay, so if you see the VPNs are down, I will initiate some ping packet so that they can come up. So I have some loopback created, and I have some loopback, and I have told that these loopback are part of this VPN traffic with the help of access list 100. So the moment I start some ping command, they should initialize the traffic, and we should see some kind of what do you say, negotiation happening. So let's try to open some Wireshark, so we can see that, and on other side we can enable debugs. Okay, we will not enable on our side because then we will be filled with lot of debug messages. We can enable some debugs here, so we can say debug crypto ICKMP. Okay, I can say debug crypto IPSec. Okay, but now what happens is I have done it on a global point of view. All my VPN, I don't have lot of VPN, only one VPN, but let's assume if I had 100 of VPNs, all of them would have started attracting the debug messages. So we will put some conditions. So we will say debug crypto condition, we only are interested for this VPN only, that is Japan to Australia. So we can just uh, put the IP address. Okay, so IPv4, and we can type the peer IP. So what is the peer IP? This is the peer IP. So any thing, or sorry, not, this is not peer for Australia, this is the peer. So let me take out the previous one, because from Australia point of view, .1 is the peer. So if I see show debugging, so this is enabled, Australia to this. Okay, okay, fine. So it says that it is enabled now. Let's initiate some packets. So I'm gonna say ping 2.2.2. I'm myself keeping a source, ping 2.2.2, source myself as loopback 0. That is what I created, right? Loopback 0 or loopback 1, loopback 0. Let's try to initialize. Okay, not good. Okay, let's put some debug on the first router itself. Debug crypto condition peer 12.1.2. 12.1.1.2, debug crypto ICKMP, debug crypto IPSec. Okay, and if I try to do a ping test, okay, looks like something is not configured. So let's see, show run crypto. Okay, is it 2.2 or 2.1? Okay, it's 2.2. Okay, so let's once validate the config. Let's hope it's not wrong. Show run crypto. So we have policy 10, we have ICKMP, we have the ICKM transform set, crypto 10, IPsec, crypto map, Japan to Australia. Okay, crypto ICKMP policy 10, 3DES, hash value, authentication group, 12.12.1. Okay, let me try to just ping this IP. Okay, I guess we have not defined IP on the outside interface because this was a brand new device, right? I don't remember we did some IP assignment on the interfaces, and also on this we have not done it. So that is one additional line which we should remember. So this is something we missed it. So on the Japan side, it is 12.1.1 255.255.255.0, no shutdown. And the same thing on the second side would be 2 and this one. Okay, so let's do that. So if you check right now, show IP int brief, basically it's a admin chat, so no way this VPN will come up. Okay, on one side, similar way on second side. Okay, now let's first see if we do have reachability between these routers. That's the first thing. Okay, 12.1.2 from Japan to Australia router. Do we have the reachability from this to this? Yeah, now we start seeing them pinging. Now let's test the VPN. Let's try to ping the backend server by sourcing our backend so that the VPN start coming and we can see the Wireshark with some IPsec packets. Okay, fine. So what was the command for that? Yeah, so we can see the packets now. See ICMP. Yeah, see it's going well now. Okay, so it says that it was negotiating. Let's see what all things happened in the backend. Since we have enabled the debug, we can see as soon as this traffic started matching that match 100 address, it said that this is a genuine traffic and it is trying to bring the phase 1 now. So it's these are all the things that will start happening. See, by default tunnel, you can see the initialization happening between the local IP versus the remote. This is a UDP 500. So remember, the UDP 500 is the protocol that is used by IKE, that is the phase 1. Phase 1 work on UDP 500, whereas IPsec, that is the second step, that works on IP protocol 50, 49 and 50. 49 for authentication header. If I would have taken authentication header, then IP protocol 49. If I would have taken, if not taken, by default it is ESP by default, then it's IP protocol 50. Okay, we can see that in Wireshark also. I'll show you. So let's start from this. All the first phase of things are happening. You can see you will see the mode. Okay, not QM. Is something which will be coming up. So you can see the 6 messages has to be transmitted, negotiated. Okay, you can see the parameters getting negotiated. So over here you see message 1 installed. Okay, similar way you will see message 2 good, 3 good, 4 good, 5 6, and then phase 1 is up. So you should get that message saying that phase 1 is up, and now we are proceeding towards the phase 2 check. Okay, so you can see these are all 4. This is 4 key exchange is happening. So that is 5 and 6 message. This is 6. So you're almost done with your phase 1 ICKMP. Okay, so it says that main mode M6. Yeah, this is the one. Okay, if I just copy this and I'll make use of some notepad. So you must get something of this type. This says that my step 1. What is my step 1? IK phase 1, or in other words ICAKMP. Now this is complete. Okay, So 6 messages negotiated, and then my phase 1 is up. Now let's try to see what is happening for IPsec. So you can see here phase 1 is up. Okay, now beginning with quick mode. Quick mode is nothing but for IPsec step number 2, 3 messages only. Okay, and now you will not be seeing it in like message 1, 2, 3. They are little different. So quick mode will have something like quick mode ready. Okay, quick mode initiator, quick mode ready. So these are the messages that's used for IPsec. You can see the proposals that's been negotiated, the different IPsec proposals, authentication. Okay, and then we should get a message where it says phase 2 is complete. This is the one. IPsec install await new state. The quick mode phase 2 is complete. So how many messages? 3 messages here. Okay, and this is the end of your IPsec phase 2 construction. So now what happens is, after this step, these two devices, one at the Japan side and Australia side, they have successfully built the phase 1 initially. Okay, they now also have successfully built the phase 2. Okay, that is this one, and now they are good for transmitting the data packets. Let's see if my ping was successful or not. So where's my, okay, we can redo that, but let's see it over here. Okay, so let's try to ping once again. Yeah, so you can see the ping is successful. So what am I pinging? I am pinging 2.2.2, which is the backend of the Australian data center or enterprise from my own backend, that is 1.1. series. So that means my data from one end to other end is flowing across the VPN tunnel, and this VPN tunnel is constructed over on internet. I'm not making use of any other investment on MPLS, or I'm not gonna invest on any hardware or a separate technology. Whatever I had, I just gave some parameters to the other engineer. Let's say if I have the access to both the devices, then I can configure myself. If the other side is being handled by other network engineer, I'll give my parameters to him. He will do the configuration on his side, and similar way he will give his side of IPs to me, and I'll do the configuration, and we can get the IPsec tunnel in 30 minutes, and we are good to access any server which is being loaded up or hosted up on that data center. Okay, now let's see those phase 1 and phase 2 show crypto commands. So now it says that this is the Japan to Australia phase 1 status. Okay, it's QM idle and it is active. So let me run once again. So it says status active. Okay, what about IPsec? Show crypto IPsec SA peer 12.1.2. Okay, so what do we see here? We don't need all these things. Okay, if you don't want to see everything, you can just filter it out with encaps and decaps. That is the important point. Okay, so you're sending 14 ping packets and you heard back the reply for all the 14 packets, so you're good with this. Okay, let's say if you would have if you have some routing issues on the other side, you have not fixed this routing. If I delete this, if I re-trigger a ping, okay, I'm sending some ping packets. do we have something? See, we can see the ping packet only in one direction. We cannot see it coming back. And if I see the statements now, you see ncaps is increasing. That means your side routing is good. Your side of part of the Japan side, you're pushing the packet, it's going over the tunnel. That's why the numbers are increasing. But from the other side, since the routing is not taken care, his side of packet is not been arriving on your end. So they have to fix the routing on their side. So that's why I said VPN, bringing up VPN is one concept and fixing the routing is the second important concept. Okay, so VPN along with routing is end-to-end communication. And if I fix this and if I retry to ping, so they are successful, and we should get, see, we can get we can see 1.1 to 1.2 and 1.2 to 1.1. So to and fro communication is happening. And if I check the packet captures, so we can see they have increased now. So this from 19 to 24, and this has gone from 14 to 19. So we can see them. Okay, but for any reason you want to reset this counters and you want to do a fresh copy of packet initialization, you can also go with some crypto commands. Clear crypto ICKMP. Okay, so it's not ICKMP. Let's go with IKE. Do I have for IKE? Okay, so let's see ICKMP. Okay, nothing for that. SA peer, and let's define the peer IP. Okay, and if I try to see the packet, now they are being reset. If you want to do a fresh copy of troubleshooting. Okay, now let's reinitialize the packet once again. Okay, so we see the VPN is building up, and if we redo the packet capture, we can see they are good. See, these packets don't have to do anything, but let's say you are doing some troubleshooting and you want to see if the packets are increasing on both the side, both the nodes, that is encap and decap. You can do a quick reset of the VPN and you can initialize the traffic, and you can see the new uh, copies of the traffic or the packets. Okay, and from Wireshark point of view, I'll show you few things. That is, in the case of phase 1, okay, so this is the phase 1. Okay, so by default it has not taken main mode, instead it took quick mode. I guess Cisco routers starts with quick mode. If it was a Cisco ASA firewall or any firewall, they would have started with the main mode. Main mode starts with 6 messages. Okay, okay, I'll do few more things here. I will change the PSK, that is pre-shared key, and then we will try to see what mode is that stuck. Okay, so as of now, let's see what is happening. You can see the messages. So there are only 3 messages. So one message for which you got the reply, the second messages you got the reply back here, and the final messages. So in the quick mode, only 3 messages, whereas in the main mode there are 6 messages. And you know what are these messages. If you have any confusion, like you're in troubleshooting, you wanna know what message carry what, there are some chart which you can refer it. Okay, so you can refer this. So this is for main mode. So if you see your message stuck at message 2, so that could be because of one of these issues. Either the encryption is not matched, or hash value, or th value. So you can fix them. Okay, so message 2, message 3, message 4, 5, and finally 6. 6 deals with the pre-shared key if the key is wrong. On one side you set Cisco, and on other side you set 123. Now they are a mismatch in the key, right? So this is something which you can refer during troubleshooting. Okay, I will do one small troubleshooting, that is I'm gonna change this value. Let me put it as 123, and we will see what happens this. So which side is this? This is Australia side, right? So I'll go to the Australia side and I'll change my parameter. So it says that a pre-shared key for this is already existing. Fine. What does it gonna do? Is it gonna change it or no? I think it has not changed it, right? So we will first try to remove this. It is removed, and now let's try to put it back. Okay, we are doing some sorts of troubleshooting, so I'm gonna do a mistake purposefully. And if I try to initialize now my packets, okay, so basically the VPN was up and it's making use of the same connection. So I'm gonna first clear the tunnel and then we will initialize the packet. Now if you see, our VPN shouldn't come up. So is it coming up? So crypto decamp, okay. Okay, so let's try to ping now. So how did it take the string? So let's see once again. I guess the string was not removed then. Okay, so the string is changed here. 1 2 3 show run. Okay, so strings are different. Okay, so when strings are different, you basically will not get a successful VPN peering. They get stuck on the phase one itself. This is so strange. Okay, I'll do one more thing, that is I will also try to reset from this side. Clear crypto SA peer 12.1.1, clear crypto IPSec S. Okay, I think in router we don't have option of clearing phase 1 and phase 2 separately. Whereas in a firewall we can clear IPsec only, or alone IPsec, and or else only the IK. But I think here there's no such option. So that is why the previous key is still getting used. Once we clear the whole thing, it shouldn't actually take the wrong one. Okay, so I think this is not effectively clearing the cache memory. Dot one. So let me try to initialize. No, so basically it's still pinging, which shouldn't ping. So this is because the router has stored the previous key. Okay, and it's not letting us to take it out from the cache. In a firewall, we can have a we can clear for phase 1 as well as phase 2 separately, which I don't see it in a router. Or what happens is, basically when the pre-shared keys are not matched up, they get stuck on one of the message. Okay, so I wanted to show you, when the key is not matched up, they will stuck at 5 or 6. Okay, so one side, that is initiator, will stuck at 5, and responder will stuck at 6, because on the message 5 and 6 is where your actual pre-shared key is being exchanged. I wanted to show you that. But here what is happening is, even though I changed the key, it's still considering the older key which was configured, and we can see that the communication is still happening. Okay, I can try by shutting down the interface. Let's see if that helps us. Show IP int brief. Okay, so this is the interface. Let's try to shut this out. Okay, now basically this will not ping because the outside interface on the other side is down, so that's known thing. But let me try to bring it up. No shutdown. So the key is saved somewhere, so that's why it's not triggering that key is to be an issue. So you see now it's once again reachable. See, actually in IPsec, the keys are very sensitive, very sensitive. Okay, if you just do a silly mistake, this would have gone fail by now. We just tried with almost everything by clearing, shutting down. Still, you see it's working like a good configuration, even though the keys are different on both the sides. That normally don't happen because these keys are very sensitive in IPsec. You don't even need to clear, or you don't even need to shut down. The moment you do reset of tunnel, and if you try to reinitiate, once again these messages get negotiated, and then the password, since the password is changed, the VPN don't come up. Okay, anyway, might be some catch issue. I guess this password got settled down with that particular VPN, even though here we see the password is changed. But I think the previous password is might be stored in some cache or something, so that it's showing. Okay, let me also try to change this password on this side, so hope that brings it down. Okay, so the password here is something else, right? Do show run. So first let me remove this, and then let's say password is something else, so we can set it as Cisco. We can try first with clearing it, and we will try to ping once again. Okay, this is very really strange. Both sides the passwords are changed and it works still. Okay, so let's just come out of this. Okay, so we have done like 99%, and 1% of troubleshooting was to show some messages. But I think there could be some limitation on the emulators. These routers don't behave the way it should. All right, so let me see. Okay, I wanted to show you Wireshark capture. So for ICKMP, the port numbers are UDP 500, and if you open up the packet for ICKMP, you will see it's by default taking main mode. Okay, and you have already seen the message transfer that's happening here. So in the quick mode, there are only 3 message. So you see message 1, you see the so this is the reply from the other side, so that would be like a message 1 from that side. You see another message 2, you will see the third or the second message reply to that, and then finally the third message. So all the negotiation happened in these 3 messages. If it would have been the main mode, then there would have been like message 1 for some transfer, then there would be message 2, then message 3, then message 4, then message 5, and then message 6. Okay, so both work on UDP 500 port number. Even this and even this, I can say that the ICKMP works on UDP 500. So if you have some firewall and you're trying to build VPN across them, so make sure, if you are trying to uh, see that ICKMP is not coming up, the one reason could be that the UDP 500 is blocked on either of the side. So you have to allow UDP 500. Okay, that's something which you have to remember. Okay, and let's also see the protocol for IPsec. So we know that it's either AH, okay, or it is ESP. So as I told you, by default, IPsec considers ESP, encapsulation security payload. And let's open up that. Let's see what are the things here. Okay, so this is the ESP protocol. Okay, ICKMP, ESP. Do we have any other packet in between? So if you see here some ARP packet, that was because we had removed the routing. So when you remove the routing, basically the traffic was started going in a different or outside of the tunnel. That's why we are seeing those looking for ARP request. So our intention is to do a routing and push the traffic inside the tunnel, because we are defined all these things for only those source and destination. So ESP traffic. Okay, so what is over in the ESP? Yeah, so this was what I was telling about. So ESP works on protocol 50, IP protocol 50. Okay, if you would have made use of the authentication header, then the protocol would have been 49. This is something from your interview point of view. Well, so I guess we have covered IPsec. So let me know if you guys have any doubt, so that we can also move towards the remaining topics. Sorry.
So,
Yes.
okay, Saga, I have a question over here.
Yes. Go ahead. Yes.
Uh, so if I want to integrate for the authentication, if I want to integrate token, how do I configure that with the VPN?
You're talking for remote access or IPsec?
No, remote access. Yeah.
Yeah, for remote access, you have to define it in a servers. I mean, there are options while you configure the remote ASA. You have an option of uh, copying the local generated certificate inside the configuration of remote access, or you can define some RSA token servers, or you can also point it to some other servers. So basically, that is how it works. The configuration for remote access while you're doing it on ASA firewall or router, there is where you define this.
Okay. So I'm gonna have to have a server in my network, and
Server in the case if you are making use of your own local certificates. If you want to go and buy something from a GoDaddy or something, you can pay them and get the certificate, and that certificate you can install in the configuration.
okay.
Yeah. So certificate depends on where you like buy it. So if you know the certificates, you can buy from
Yeah, yeah, from
GoDaddy. Yeah.
GoDaddy or another
Yeah.
provider.
But if let's say you're doing it for your lab purpose, you can install a Windows server, and on the Windows server you can generate some certificates, and that
Some
certificates you can
certificate,
copy
yeah.
paste on the configuration of remote access.
Okay. I think someone asked a question on the chat.
Okay. So the question is, how do I make a route based site command?
Yeah. Sagar, can you hear me?
Yes.
Oh, so can I ask a question like route-based site-to-site VPN?
Yes, you can make either policy based site to site or route based site to site. Right now, what I did in the class was policy based site to site. So you can also make route based. For route based, you need to have the VTY, or you have those interface which will do the work of routing. So the configuration would be like you have to define your IPsec IP the phase, I mean phase 1 and phase 2, and you have to make use of the routing. You can make use of VTY or sub interfaces, and where you can define the routing, and you can enable this. Might be I'll give you the configuration for that as well.
Okay, please, if you have that one,
Yeah.
that one.
So
Thank
yeah,
you.
so in short point, so in the case of policy, I defined my access list. I said that 1.1.1 should communicate to 2.2.2 over on so and so interface. But if it was a route based, then I go with some routing command, that these are my destination, and go it via this one. Rest all remains same, that is for phase 1 and phase 2. The configuration remains same, that's just like one or two lines which will be modified for policy to uh, from policy to the access, I mean policy to routing, sorry. Okay. So any problem with my audio? Am I very low? Because I see some students said that my audio is very low. Is it true?
I can hear you very
Okay.
well, man. I don't know why.
Okay.
Okay.
All right, guys. So I guess we are good with IPsec, and I have not bored you guys with a lot of topics inside IPsec, but that's how IPsec is. It's too many of topics, too many of protocols, so many of concepts there. Okay, fine. So let's go with some smaller topic now.